e. Okay, and then the applications of those. And so, if you remember, e was always written to a power. And we're going to look at what happens if it's not e. What happens if it's like the number 2 to a power, or the number 3 to a power, or the number 4 to a power. And so that's what it means when it says bases other than e. And so, first of all, an exponential function to base a states if a is a positive real number and x is any real number, then the exponential function to the base a is denoted by a to the x, and it is defined by a to the x equals e to the natural log of a times x. Now real quick, we know that e and natural log cancel each other out. Okay, they're inverse operations. So really what ends up happening here is the e and the ln cancel out. You bring an a down, and that's where the a to the x power comes in. Okay, and so now we're going to actually define a logarithmic function to base a. That basically states if a is a positive real number and x is any positive real number, then the logarithmic function to the base a is denoted by log base a of x and is defined as, okay, log base a of x equals 1 over the natural log of a times the natural log of x. So real quick, if I get rid of that fraction and I write it this way, where have you seen that before? Where have you seen natural log of x, which is the outer, over natural log of a, which is the inner?
In 5/4.
Now when I say natural log of the outer, okay, x is the outer and a is the inner. Where have you seen that before?
Condensing?
You're getting closer.
Expanding.
It's actually something that you learned last year, believe it or not, for the first time.
Is it like moving the things around? Like x and all those rules?
It's actually known as the change of base formula. Okay, that's what it is. Okay, so that is the change of base formula. It's just the natural log of x over the natural log of a. Okay. So anyway, here's a few properties. I don't know if you necessarily need to write those down because we've kind of discussed them already. Basically states y equals a to the x if and only if x equals log base a of y. So where that comes from, if you remember, how I can bring that exponent of x down is I'm going to take the log base a of both sides. So here's your a to the x. If I want to go ahead and take log base a of both sides, on the left side I've got log base a of y, which matches up with this. On the right side, log base a of a cancels, and that leaves me with x, which matches up with this. Okay. Now remember, a to the log base a of x, number 2, equals x because a and log a cancel each other out because they have the same basis. And then last but not least, number 3. Once again, log base a and a cancel each other out. So it says to solve for x in each equation. So we're going to go ahead and look at this first one. It says 3 to the x equals 1 over 81. And so real quick, what I need to do is I need to go ahead and write this right side as 3 to some power. Okay? And so I know that I have 1 over 3 to what power? 4. Okay? So in order for us to solve this, I need to make sure that I move the 3 to the 4th up. How can I move that up? Negative 4. So in this case, what does x equal? Negative 4. Okay? All right, let's go ahead and look at another one. Log base 2 of x equals negative 4. This is actually called logarithmic form because it's got a log in it. we are going to write this in exponential form. So in order to get rid of the logarithm, what am I going to do?
Can you make it 2?
Yep. I'm going to do 2 to both sides. Now on the left side, the 2 and the log 2 cancel. It gives me x. On the right side, I'm left with 2 to the negative 4th power. And so I need to calculate that. And so to calculate that, the negative 4, what I can do is move it to the denominator. So really it's 1 over 2 to the 4th. So what is your answer? 1/16. There you go. Okay, so now what we're going to do is we're going to talk about the derivatives. Okay, and so the derivatives for bases other than e. And so the biggest ones you need to worry about are 2 and 4 because those are a to the u and log base a of u. But if you want to go ahead and get those down, and we'll go ahead and look at a few examples of that.
So do we ignore 1 and 3 and just make
2 and 4, are the most important ones because those will always work. 1 and 3 are just for the cases of if it's like a to the x, and it has to be to the x power.
2? So write them all down.
Well, depends. I would just make sure you have 2 and 4 down. And this is the other thing. It should be on your formula sheet anyway with your derivatives and integrals. So that derivative sheet that you have already has all this written down. So if you do have that derivative sheet handy, this is actually number 11 and 12 on that derivative sheet. So this first one says, find the derivative of each function. So for those of you that already have this down, I would like you to go ahead and just try to find the derivative based on using those formulas. What do you think the derivative of 2 to the x should be? So just hold on, we'll see how. All right, so what do you think the derivative should be? Yep, that's it. ln of 2 times 2 to the x power. Basically, you're using this one, or you could use this one too. In this case, u is nothing more than x. Okay, so all you're doing is taking natural log of the base times the base to the exponent, and then the derivative of x is 1, so that's why it doesn't factor in.
So what's the answer?
That's the answer. Okay, let's look at this one. 2 to the 3x power. So this is the one where you're going to have to use the a to the u. I know that u in this case will be what? 3x. du is 3. So the derivative is going to be the natural log of the base. So the natural log of 2. And then I've got 2 to the 3x power. And then what do I need to do? Times by 3. Okay, so my final answer, yes, you do need to kind of arrange that a little different. My final answer will be y prime equals 3 ln of 2 times 2 to the 3x power. Okay, and you could put parentheses around it like that if you wanted. But that will be your final answer. Questions? Alrighty, real quick, let's go ahead and look at this one. Y equals log base 10 of cosine of x, yes. So, yep, u is cosine. So u is cosine. Derivative of u is negative sine. So now let's just go ahead and utilize that formula they give us. We're looking at the log base a of u formula. It says I've got 1 over ln of a. So 1 over ln of what? 10. Next, it says you're going to take that times u in the bottom. So I've got natural log of 10 times cosine of x. Then it says I'm going to take that function times du. So I'm going to put negative sine right here. Now, I can go ahead and simplify those around a little bit. And you mentioned about putting it on the top. Well, let's think about things here. If, in fact, that were up here, I have sine over cosine, which is tangent. So it's really going to be negative tangent of x over ln of 10. Questions? Okay, I don't expect you to memorize these formulas. Okay, I'm going to be honest with you. You're going to have your formula sheet. You're going to be able to use that on your test. I just expect you to be able to apply them. Okay, last thing we're going to talk about real quick. This is all the further we're going to delve into integrals with bases other than e. But the integral of a to the x dx equals 1 over ln of a times a to the x plus c. Okay, so we just need to find the integral of 2 to the x. So utilizing that formula, what's the integral going to be? There you go. That's it. Okay. Questions? That's all we're covering from section 5.5. We are actually going to cut out 5.7 and 5.8. So actually 5.8 is what we're cutting out. We will do 5.6 and 5.7 next week. Remember, you're looking at a test late next week, early the following week.